so we've finished that, and now here's another one. Okay, so every word in these problem statements does change your approach to these. So if you wish to buy a house and you can afford to make a down payment of $50,000, your monthly mortgage payment cannot exceed $2,000. A 30-year loan are available at 7.5% annual interest rate, which is compounded monthly. So now we're pulling together that this is the APR again, at your annual percentage rate, but this time it's compounded monthly. The highest price that you may consider is most nearly. So we're looking at, once again, similar to what we did before, 7.5 divided by 12, so it's the 0.625% per month. You're going to apply this equation, come up with a factor table number. However, this time, since you can't exceed it, you're going to use these numbers as though it were an algebraic equation. Okay, you can do that. And so you have your present value times your factor number is equal to the highest dollars minus 50 and times your factor table number that you calculated. It's got to be less than or equal to $2,000. The highest number, less than or equal to 2,000, divided out plus the 50 gives you $336,000. So think of these as just simple, let's express these as X or Y, A, B, C, whatever you want to think of, and you can use this in an algebraic format, okay, to solve for the problem. An alternate way, okay, there's many ways to calculate any of the questions on the exam, and in this particular case, there's an alternate method, and it uses 1 year as the time period. So then you have n is equal to 30 years, you get to 7.763%. You create an AP, right? The annual rate is 2,000 times your FA of 0.625, 12, multiply it all out. And here, once again, it's an algebraic methodology that you can use, and you get exactly the same answer. Okay, same answer as before, okay, within a rounding error, okay, within a rounding amount. Okay, next, we're going to increase this and give you some more information related to the every drop of ink. So an engineer deposits deposits an X amount every 6 months for 3 years, so she'll have $10,000 at the end of this period. The interest rate is 5% per year, which is rebalanced every 6 months. Now, if anything, okay, that's the word, that's the operative word. That's where everything, your entire calculations is based on. Whenever you see, and we introduced this before, and a few people call this out, like what does that word mean? How did that all come to be? That one word changes your entire analysis. It's basically changes it to where now you're having 6 deposits. You're basically told, well, it's 3 years. Right, but it's rebalanced every 6 months. So that means that the interest is added to the principal, and then the principal with the interest accumulates to the next period. So in this case, you're basically doing 6 deposits, and your 5% is literally divided by 2, twice per year, right? This is 5% per year. Okay, if it's 5% every 6 months or a half year, right, you're going to see that it's 2.5% per 6 months, right, or a half year. So that changes it, and you're approaching it exactly the same way as you did before. AF, right? This is an AF. You're given the future amount. You're looking for the annual amount. And so 2.5, 6, you go straight to the book, and you come up with your final answer.